Hello everyone and welcome back to the course. In this segment, we embark on a journey through the curvature of a function as we explore inflection points and concavity. Let us consider the following concept. Let f be a function defining an interval a, b, and let c be a value in such an interval. Then we say that c represents an inflection point of f if and only if the second derivative of f evaluated at the point c is either equal to 0 or it doesn't exist. Geometrically, the inflection points are those in which we can perceive a change in concavity for the function. It can pass from concave up to concave down or the other way around, as we can notice in this graph. Now, for determining if the function was increasing or decreasing, we had the criteria of the first derivative. In this case, for determining if the function is concave up or concave down, we are going to use the second derivative as the criteria. If the second derivative of f is positive in an interval, then the function f of x is concave up in such an interval. As well, if the second derivative of f is negative in an interval, then that function is concave down in such an interval. Let us consider our familiar function f of x equals 2x cubed minus 3x squared minus 12x plus 5. If we perform the first derivative and then the second, we get that the second derivative of f is equal to 6 times 2x minus 1. Thus, the second derivative of f is equal to 0 if and only if x is equal to 1 over 2. Thus, 1 over 2 represents an inflection point for the function f of x. A natural question arises: how do we find the intervals of concavity algebraically? Well, we have to consider the following table made of the intervals minus infinity, 1 over 2, and 1 over 2 to infinity. We have to take a value in those intervals and we have to plug it in the second derivative. And depending on the sign of the result, we can determine if the function is concave up or concave down in those intervals. For instance, if we take the value of 0 in the first interval, we get that the result is negative. Thus, the function must be concave down in such an interval. As well, if we take the value of 1 and we plug it into the function, we notice that the result is positive. Therefore, the function must be concave up in such an interval. You have made it to this point. That's impressive. Or should I say, that's an inflection point in your career. See you in the next video, guys. In the meantime, try to find the intervals of concavity of those functions.